very basics of R. R has basic commands and data structures, 6 basic data types, out of which a couple are more important than others, but it has a character, a numeric, an integer, a logical, and a complex. I've never used a complex before in my entire working life with R, but characters are very useful. These are essentially the equivalent of Python strings, or yeah, numerics. Integers speak for themselves. I've actually never used integers either myself, I think. So numerics are certainly very widely used, and logicals are true or false. Then there are many data structures in which you can store these data types. So there are atomic vectors. Atomic just means that every element in a vector is of the same type. So you can have a vector that says A, B, C, D, having 4 different elements, and they're all characters. You cannot have a vector that is A, B, 1, 2, because there you would have 2 characters and 2 numerics. A list is more flexible than that. A list is able to contain many different data types. It's not very widely used in R like it is in Python, because R is very feature. What is nice about it is that it's vectorized. That's why you won't often see lists, but they do exist. Then there's a matrix. A matrix is an atomic vector with a dimensionality component. So you can have a 2 by 3 vector essentially. So a matrix is also atomic. All the elements will have to be the same data type. Actually, the slides after this show this in a little more detail, but this is just a brief overview. A data frame is what I would use most and what most people would use. This is not so different from a matrix, except that I think it can contain different data types. And then a factor is also, how do I explain it? It's also a vector, but it will be, maybe I'll save this for later, but I'll try to explain. If it's confusing, that's okay. I think a factor is a vector where each element can only take on a certain number of states. So you might have a good example is a factor vector could be colleges in Boston, and you might have only 20 or so of them, Harvard, MIT, Northeastern, whatever other colleges there are. The vector cannot contain Stanford, for instance. Hope that explains it a little bit. So let's go over these vectors in a little more detail. You create a vector by assigning C with in parentheses the elements of the vector. So this is a numeric vector. You can have 1, 2, 3, 4, 5, and assign it to the variable x. Then you can index this vector with square brackets. So you can print the first element of x, and that will be 1. Then you can perform operations on the entire vector at once, on each element. So if you square this entire vector x, you will get the squares of each of the components. So 1, 4, 9, 16, and 25. The same if you take the square root. It will apply to all the elements of the vector. And this is quite neat. You won't even have to do a for loop or anything. It just does it. A vector can be logical as well. So logical, remember, is just a Boolean, a true or false. So if we think about what's going on here, it's taking x. X is our vector defined up here. And then it's subsetting it. It's indexing it by a logical vector. This logical vector, x is smaller than 3, will be a vector showing the places where x is smaller than 3. So this vector will just be true, true, false, false, false. Smaller than 3, smaller than 3, not smaller than 3, not smaller than 3, not smaller than 3. So if you index by a vector that's true, true, false, 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 it's just going to show the first 2 elements that are true. So in this case, the first 2 elements of x, 1 and 2. Feel free to re-listen to this later as well. So then, as I alluded to, a matrix is an R vector with the dimension attribute, also atomic, meaning it can only contain one type of data, one data type. So if you want to create a matrix Y, this just means you fill it up with values 1 through 8, with 2 rows and 2 columns, and this means you fill it up by column. So you can imagine you could fill up a 2x4 matrix with the numbers 1 through 8 in 2 different ways. You could have the first row 1, 2, 3, 4, second row 5, 6, 7, 8, or you could have first column 1, 2, second column 3, 4, third column 4, 5, 6, last column 7, 8. So this just specifies how you want to fill it. This function can show you.
就是它，不是它有什么，就是相当于这那个叫什么快捷键，就看他平常一般看什么。
哦，看你大屏。Fuck.
Okay, I'm not really hearing that so well, so I'm just gonna keep going. So you can index this matrix in several different ways. You can take the element in the first row and the second column. In this case, that will be 3, because remember, we index it by column or not by row. You can access the entire second column. Then you will leave this first place blank. You use a comma and then 2. Oh, damn, I keep moving it around. Let's go back. And then the command dim will give you the size of Y. So note here are 2 rows and 4 columns, just like we specified up here. And this operator at the bottom, the %*%, this is for matrix multiplication. So this is often an issue. You can't just use a star as you would intuitively think for 2 matrices. You actually have to use this operator. So as we alluded to, a list in R is not super widely used, but it does exist. It's a generic vector containing other objects. So this is just a contrived example showing how a list can contain first a character vector, a vector with 3 elements, namely January, February, March. The second element of the list is a matrix with 2 rows. And then the third element of the list is another list with first a character and then a numeric. So as I said, you might not use this very often, but then there are several functions. You can call the function names, which you can then assign the different names of the elements. And then you can again show the entire list as follows, and then it will show you all the elements. This is much more widely used. A data frame. This is just a list of R vectors of the same length. And note again, these don't have to be. This entire data frame is not atomic. It can contain many different elements. So this is very useful for most data sets you might have, whether it be the weather, whether it be the stock market. You might imagine many different vectors, not with all the same data types. They're probably not all just numbers. They might also have a name. So that's why a data frame is very useful. If you're following along, I encourage you to play around with this, to type data empty cars and then run it, because it's a very famous data set, and you can see how a data frame is structured. I already show you here. Str empty cars will give you a list of numerical vectors. So the data frame will have many different columns. I think this is miles per gallon, cylinders, dispersion, displacement, I'm not sure, but lots of different numbers associated with different attributes of the car. Feel free to ask me any questions if you cannot seem to load this data set. But for now, I'll move on. So here, if you do empty cars 1, 1, you'll get the first row and the first column's elements. So you see that it's this one, it's 21. The function head is very nice because it can quickly show you the first, I think by default 6, but you can specify with another comma and then the number of rows you want, but by default 6 rows of the data frame you have. And here we're actually not showing the entire data frame, but we're just taking the first column, the miles per gallon column. So that would show you this if you were to run this. This is a little bit different because now we're not just subsetting the first column of the data frame, we're subsetting that again, taking just the values of the first column of the data frame, just taking the atomic vector. You would do that by using double brackets.
Martin,
Yes?
what does this one that keeps popping up mean? Just like, is it just the first line? Is that what that means? The one in brackets for when you get the results?
Yeah.
No.
All right.
Right next to the output. So if you get an output here, we have an output of the.
Oh, okay. Here, what does this
mean?
Yeah. Good question. I think. Yeah, I'm not quite sure. Is that meaningful? I'm assuming it's just the first line of the output, but
okay.
Think about that a little. Yeah. I wouldn't.
I think it's for the first element. If we get multiple lines in the return, then there would be the indexing for the start of the next element.
Well,
like, I don't. For example, if you show a 10.
Yeah.
So we tried to do the second element of it in the previous slides, and it was still 1.
Go back to
But Mark, I think that's because it's the first element of your answer. So like, for example, on the line that produces the answer, if it goes onto a second line, then there would be another number in a bracket that would be like 9 or 10 or 11 or something. That represents the index of the return.
Okay. Yeah.
Oh, okay.
Thank you. It's always nice when other people can step in for me. I don't know.
Martin, what does head do? Like, what does it mean specifically? Like the command head.
The command just means print out or show, or the first X or first you can specify, but by default it will take 6 rows of the data frame. So if you have a very large data frame with say 200 lines, it's very inconvenient to print the entire thing. To get a good sense of what it looks like, you might call head, and then it will show you just the first 6 lines. So you'll see all the columns. Yeah. Then there are several apply functions in R. I'm myself not a big fan of them because I prefer to use all the functions that we'll get to later in dplyr and tidyverse, but this is built in R without requiring any other packages. So this allows you to apply a function across all columns, for instance. So in this case, we would sapply the function sum to all the different columns of empty cars. So in this case, it would add up all the 30 or so rows for MPG, for SIL, for DISP, etc., etc. Yeah.
Wait, Martin. Yeah, someone. That car does have a 6. Is that supposed to be right? It's 642.9 miles per gallon.
No, so that's the sum of all the 30 cars in the data set.
Oh, okay.
Because
we just like that sounds odd.
Because that's the use of sapply, right? You can take the function sum and apply it to all the columns of the data frame all at once. And in many other programming languages, you would have to write some for loop for this. And
I see.
Their internal implementation of a for loop, essentially.
Okay. And then we can just change sum to some other function.
Yes. Yeah, you can do many things.
Okay, cool.
You could do mean, for instance, or whatever.
Yeah.
Okay, this is how I prefer to, and basically I think everyone I know prefers to manipulate data. This is dplyr. Dplyr is also included in what's called the tidyverse or a tidy universe. This is a group of packages with all sorts of useful functions that can make data transformation and just doing different wrangling tasks very, very easy and quick and very readable. So it's very, very useful to know these. And there's only a couple operations that are really widely used, so I'll go over them right now, and I'll have an exercise for all of you. So we're again looking at the flights data set. We can take the head to see what it looks like. It's too many columns to print on the screen here, but see there's a year, month, day, departure time, etc., etc. one operation you might want to do is filter. So here we're simply selecting specific rows based on conditions that you can specify. So for instance, if we wanted just flights on January 1st, we could do filter from our data set flights. Month is equal to 1. Note the double equals here. This is very important. And day is equal to 1. But you could do this for all sorts of columns and with as many conditions as you would want. So another thing you might want to do is select different columns. Some columns might be superfluous. You might not need them. You might only want to see a couple of them. So you can select from our dataset flights, columns year, month, and day. If you want to deselect or just get rid of one column, you can do select flights and then minus year, for instance. That's much quicker than manually typing out all the other columns that you do want. This is useful. Mutate, if you want to add new columns, especially based on other columns that you already have. So for instance, in our flights data set, we have an arrival delay column and a departure delay column. So think about it, if a flight has less arrival, let me think about that. If a flight has more arrival delay than departure delay, that means there's some gain in delay. That's what I was trying to show here. So if you want to see how much more delay did this flight obtain while flying, you could create a new column called gain, and it will just automatically subtract the departure delay column from the arrival delay column. Same here, you could take the average speed by taking the distance column, dividing it by the airtime column, which is probably in minutes, and then multiply by 60. So the mutate function is useful for creating new columns based on columns you already have. Then you might want to arrange or sort a data frame by columns. So usually you might want to sort by one column, for instance, the year. But in this case, we want to arrange by an ordering of different columns. So we might want to arrange by year first, then month, then day. So this will arrange ascendingly, I think. So it will go from low to high. You can also arrange descendingly from high to low. I think then you will have to supply an argument called desc, DSC, but I have to double check on that, I think. But yeah, so this is useful for arranging a data frame. It will sort it nicely by the values of a certain column.
And Martin, all of these functions you're showing us is only for this data frames, applicable to data frames.
Yeah, I think so. I think tidyverse works with data frames, but or I think more properly called tibbles. Tibbles are just data frames that look nice when you print them. But usually when you have a matrix in R, you might also be able to convert it into a data frame. Yeah, for now, just let's keep working with data frames. So here, yeah, as I alluded to, if you want to sort in descending order, you just put desk in front of the column you want to sort by. And then this is the most powerful one. It's a little bit harder to understand, but you can easily summarize certain columns with the summarize command. Here you can, for instance, easily take the mean of the departure delay and quickly show that in a data frame. So if you summarize from your data frame flights, you will call your new summary essentially delay, and you'll take the mean of the departure delay column. And this just means you get rid of all the missing values, all the NAs in the data frame. Then it will quickly summarize this for you and neatly. So this is quite powerful, especially if you combine it with group by. So let's walk through this slide. The true power of dplyr is its capacity for split apply aggregate workflow. First, you can group by a plane and then summarize the number of flights, average distance, and average delay. So what we're doing here is we're grouping all the flights by tail num. I think it's just the serial number of a plane, essentially. Then we are summarizing this grouped by data frame we're saying count is equal to n. That means the number of rows per tail num. Dist we call the mean distance, and the R delay we call the mean arrival delay. So then here you can see a very first we're doing some other steps, some filtering step, and then you can see a very neat tiny data frame that's grouped by the tail number. So for this particular plane, you have 371 flights with this average distance and this average delay. So this is quite powerful. The pipe operator. This is an example of what you don't want to do, and then we'll show why using the pipe operator is useful. So this comes into play when you are trying to do several consecutive operations. You might want to filter first, then select, then summarize. Naively, you might do this way. You might just take your flights data frame, group it by certain columns, assign this to one new data frame that you call A1, on which you then select. You make a new data frame called A2, on which you then summarize. You make a new data frame called A3, and you have a bunch of these data frames that you're defining that you don't really use anymore later. And this is not really good practice. You're wasting all these variables, taking up storage. It's very unreadable. Fortunately, there's a nice solution for this, and that's called the pipe operator. One other example that's very ugly. You are making this very unreadable by doing all these filter, summarize, select steps all inside each other, and it just doesn't look so readable and beautiful. So this looks a lot better. With the pipe operator, you can turn a function of x and y into, you can just write it as x, pipe operator, function of y. So what that just means is you can start with the flights data set, and then you take that as input to the next operations you're doing. So then you take this flights data set, you can group by year, month, and day, and then whatever that spits out, you can take it as a new input to your new operation. You can select several columns, and then whatever that spits out, you can take as input to your next operation. So this is much more readable because it just shows you start with the flights data set, then you're grouping by certain columns, you're selecting certain columns, you're summarizing, you're filtering. It's much more readable for others and for yourself as well. Then, yeah, you can combine it just with several other functions as well. So if you want to think about this, you feel free to do so. So if you have your flights data set, you can filter by the origin. So I think this is Newark or something. And you can group by destination, summarize n equals n parentheses. This just means take the number of rows and then arrange. So what this ends up doing is it takes all the flights with origin Newark, it groups them by the destination, then it summarizes them by taking the number of rows. So, and then it arranges them in descending order. So what this gives you is the top 10 destinations from Newark in terms of number of flights. So yeah.
Just a quick question about the group by. When it group by, like in that first step, right? Does it just like order all of the data? So like now when you look at the whole data frame, you can see everyone, you can see like the first n columns are just like Ord, and then the next n columns could be like Boston, so on and so forth.
Yeah, good question. So I'm not sure if it's possible to just do group by. It's almost or always it's used together with summarize, I think. And so it will essentially, so it will group it by destination, and then you will give it some command to summarize on. So it's a good question. Oh, somebody still in the waiting room.
Yeah. And I guess what does it mean when you say group by two variables? It just mean like they're just gonna get every pair combinations of those two variables. So if you did group by destination and like year, it would do like Ord 2019 or 2020, so on and so forth.
Yes, that's exactly right.
Okay.
Okay.
Question on the previous example.
Yeah, go ahead.
With the pipe, one back.
Mm-hmm.
So the select gives you a data frame as the output, right?
Yes.
And then in summarize, like, so it automatically populates like the first argument of summarize with the data frame, because usually summarize I think has 3 arguments. So how can we know like when pipe will work, when it will not work?
I'm not sure if I fully understand your question. You're saying it automatically populates the first argument of summarize.
Yeah, because I think summarize has to be so the first argument of summarize has to be a data frame itself, right? And then
No, yeah, so that's exactly why we're using the pipe. So usually you would have to summarize, which takes in some data frame. But oh yeah, now I understand your question as well. So yeah, it automatically fills in the first argument of summarize, which would be the data frame you're using, because you're using the pipe, and the pipe tells it use whatever data frame you have obtained here from all your functions, and take that in summarize. Yeah.
So now, what if hypothetically there was a function where the data frame came as the second argument? Would that be possible to do with the pipe?
Ooh, good question. I don't know the answer to that, frankly. I don't think I've seen that before either. Where?
So maybe okay. So maybe that doesn't happen in practice.
Yeah, it's a good question. Yeah, I'm not sure. I'll have to think about that.
Okay, thank you.
I have a little exercise. If you're very sneaky, you can see the solutions below this in the R Markdown. But I was planning to give you 5 minutes to just go and try this. This might be way too long or way too short, depending on where you're at. That's totally okay. But I think the best way to practice these operations is to apply them. So I've included a data set from an actual clinical trial. This contains several variables, so treatment, sex, age, and several trial-specific indicators. I think this is a breast cancer chemotherapy trial. And then the column E-type indicates the event of a death or a recurrence. So a bit morbid, but bear with me. We've seen these functions for transforming data. And then I'm going to give you the following exercise that I'll give you 5 minutes to do, so I can have a glass of water. And make sure to use the pipe operator on this so that it doesn't look very messy. So let's remove the column called study because it's not useful. Let's filter out all the, sorry, I'm already giving away which operations we're using, but that's okay. Let me not do that. We only want rows with E-type 2. Let's create a new column and round the time to months. For simplicity, just assume a month has 30 days. Then we can sort our data frame by age from low to high. And then we can try and show a simple summary. So we want the average survival time in months grouped by the different treatments that people obtained. Yeah, 5 minutes up. Let's keep moving. Actually, oh yeah, I'll show the solution first. You're already able to see this, but let's walk through it. So doesn't it look neat? We have our colon data set. We deselect the study column with using the minus. We take whatever data frame that puts out using the pipe, and we take that as input for our next operation, where we filter out the E-type, or we filter in the E-type, I should say. We take only those E-types that are 2. We mutate. We create a new column called time, which is our previous column called time divided by 30, and we round it so it's neat. Then we arrange it, so sort it in by age. Then we can, this is the harder one, we can group it by treatment and then summarize. So by treatment, it will show you the average number of months, which is the just mean of time. So then this is what it will output. Good thing is that people in this clinical trial ended up living longer with the new treatment. So I guess that's a good thing. Let's keep going on. And actually, yeah, I'll go. We're almost done with the R part after we quickly show Gplot. Then I plan to cover a little bit of Bash, but before we do that, I'll show the steps for getting onto the computing cluster, because I think that's more important, and in the interest of time, I'll cover that first. But let's stick with Gplot for now. This is too much to explain in a slide or two. You really have to practice with it, but it's a really neat way to plot your data frame. They have all types of different plots that you can choose from that are pre-made. They will give it nice coloring, and you can basically specify all the different parameters that you want. So for instance, this is a plot of arrival delay in minutes by month. It shows the box plot, and it colors it by the different airports. Yeah, so this is how you would do it. Note that instead of the pipe in Gplot, you will use a plus. I'm not sure why they chose this. I guess it's not exactly the same as a pipe, but if you want to do different operation in Gplot, you have to do a plus. Yeah, I know that you can. This takes practice. A little hard to wrap your brain around. Here you're saying you're specifying what you want on the x-axis and what you want on the y-axis. On the x-axis, you want month as a factor. So remember, a factor is a vector with only a specific set of possible states, essentially. So this will be a factor with 12 different states. I'm presuming you could also use this as a numeric, but here they chose to do a factor. On the y-axis, you have the arrival delay, and the color is the origin. So you don't have to specify anything. You just say, I want the column origin to specify the colors of this plot. Then it will automatically do that for you. I'm sure you can even assign which airports you want to be which color, but it's not showing that here. And then you're saying you want a box plot, you want this title, and these X and Y labels. This is another example. Yeah, I'm not sure we need to run through that now, but so Gplot is super useful for plotting and much more beautiful and versatile than R's inbuilt functions for plotting. So that's why we recommend using it.